everybody, welcome to the channel if you're new, and if you're coming back, welcome back. So sorry for the delay in uploading the videos. I was out on holidays, but anyway, I have finished my leaving cert. I was the batch of 2023, and turns out the exam was a bit more difficult and it was a bit more different than your classic exams. So I can only imagine the exams are going to get harder and harder. So during my summer holidays, I'm just going to be making these videos for people who want to get better or understand the concepts a bit more, especially the maths part. So I will not be covering any of the theory part here, or it'll be very minimal theory, but I'll be focusing more on the maths because at the end of the day, when I was doing my leaving cert, the maths was the difficult part. So if you look at this exam paper over here, it's the state exams, so all credits goes to state exams, whatever you see here. So this is 2020, question 1, and this is the washing soda experiment, all right? So the washing soda experiment is the exact same as your anhydrous sodium carbonate and HCl experiment, except you use the crystallized version of the sodium carbonate. And it is a shame that the calculations really puts off students from doing this exam question really well, and it really ruins the marks for them. So if you get that right, it'll be very easy to deal with this. So as I always say in my videos, please do watch my video on the introduction of titrations. If you don't know what titrations are, you won't be able to do these exams, especially you fifth years who may not know it well or get confused. Please watch it well before you continue on with these videos. And I highly recommend you to stop the video and do each of these questions by yourself so you can get more of a focused approach on why you got things right or why you got these things wrong. Alright, getting on to the question now. I would ask you to highlight the main parts that you think is important in this question. So I'm going to do that now. I'm going to give you a few minutes to do that. Alright, so I haven't done many of the questions in a very long time, since the 20th of June. So I'm going to be doing this raw um, in person just now, so that it's more realistic. Alright, so washing soda is a cheap household chemical used for laundry, removing grease, and softening water. So when I'm seeing washing soda, I'm thinking, okay, it's not a primary standard, because remember, a primary standard has to be anhydrous and should not have any water of crystallization, except for the exception of iron sulfate crystals, the ammonium iron sulfate crystals, which is what I had for my exam in 2023. But that aside, which you can see in my other video as well, but this is hydrated. So the problem with hydration is that it's extra water, and the whole point of this experiment is to find how much water, how many molecules of water is added to that anhydrous sodium carbonate to make that crystal. Alright, so the whole idea is to find the average value of X here. Usually it would be 6H2O or 12H2O. So the more questions you do, you'll get a general idea, and eventually you'll be like, okay, my answer's too way far off or way too close or something like that. Okay, so don't rely on that either. It's always getting that method right rather than, looking at the past exam papers. I've learned that a lot since my actual exam. So don't rely on the other papers. Practice, know the stuff well by yourself. All right, so the numerical things is there's 3.46 grams of the crystals to make up 250 of the solution. So that's the volumetric flask, and 25, which is the good number, I suppose, excuse me. That's the good number, so that's going to be pipetted into the conical flask. If you don't know the good number, again, back to the video. Sorry, I'm not self-plugging, I'm just telling you so that you don't feel confused. Alright, it says previously standardized hydrochloric acid. This question had that answer. It says, no, or the question had one of the questions saying, okay, it says it's previously standardized. How was it standardized? It's the anhydrous sodium carbonate. So remember, all of these experiments are connected to each other, so that's why you need to watch them in a playlist or understand every single one of them. So since this washing soda is not a primary standard, it needs to have one reagent that whose concentration is already known, and that is the hydrochloric acid. Alright, moving on to calculations. On average, there's 21.5 cubic centimeters of 0.12 m of hydrochloric acid. M means molarity, so that's moles per liter. So that was required to neutralize 25 cubic centimeters of the washing soda solution. Alright, so this question, be very careful. It's not as easy as you might think. This is not your classic washing soda experiment. I will add that. But for now, this is not the easy one, so be very careful. Read your question carefully. Alright, it says it asks average number of moles used of HCl in a titration. So in one titration. So we know this is the amount that is used, and this is the concentration or the molarity. So the first formula that you should have in your head is this. N equals CV divided by 1,000. Don't just learn it as N equals CV because everybody forgets the 1,000 and then everything goes wrong. Alright, so if I do that, N would be N equals concentration is equal to 0.12 multiplied by volume, look at that, 21.5. You can easily tell which is which by your good number, bad number technique by 1,000. Oops, sorry. N equals 2.58 multiplied by 10 to the power of minus 3 moles of HCl. Alright, so that was very straightforward. So those are like the easy marks. Now, question 2. It asks the number of moles of Na2CO3 neutralized in each titration. So remember, you might be thinking, why did I use this instead of, let's say, V1M1 over N1 equals V2M2 over N2? Because when I'm reading this question, I'm scanning through for information, right? So for hydrochloric acid, I am given this, and I know that is concentration. So that has already given me a hint that I can use this instead of V1M1 over N1. But look, in Na2CO3, I see nothing with a big M next to it, so I don't know the concentration. And the whole point of this experiment is to find the concentration of, excuse me, the whole point of this experiment is to find the number of moles of water, but, you know, we should find the concentration along with it as well. So the number of moles of Na2CO3 neutralized in each titration. So that is referring to 25 cubic centimeters, all right? So in this experiment, or in this answer, we need to use V1 M1 over N1 equals V2 M2 over N2. But remember, this formula will only give you answers in liters. So make sure you divide to get the answer in whatever volume that they're asking. But we don't have to bother about that information just now because it's just asking for the number of moles of Na2CO3 neutralized in each titration. Remember, we know the number of moles of HCl that is used in each titration, so it's only about dividing it by the ratio. So if you go back up, sorry if I can't do that. If you go back up, see that? It's 2:1. So all you have to do is divide it by 2. Put that into your calculator, and that will give you 1.29 times 10 to the power minus 3 moles of Na2CO3 in 25 cubic centimeters. Okay, looking on to question 3. So for this part, they're asking you to find the number of moles in 250 of the solution. So you can go in the longer route of V1 and 1. That's just going to waste time, but think about this. We already know what's 225. We just have to make that 250. So you have to multiply 1.29 times 10 to the power minus 3 by 10 because 25 multiplied by 10 is equal to 250. And that would give you Alright, so that would give you 0.0129 moles per 250. Remember, this is not the same as molarity. It's not big M because it's not per 1,000. If you want to find that, you have to multiply by 4, but that doesn't affect us now. Next up, find the mass of Na2CO3 in 250 of the solution. So to find mass, you go back to your favorite triangle. Mass divided by moles multiplied by relative molecular mass. and you cover what you need, so that's mass. That gives me the formula N multiplied by mR. Alright, so the moles comes from the answer above, per 250, and then when you're finding the molecular mass, please write down. Doesn't matter if you know it, write it down. If in case you make a mistake, you will still get the marks. So that'll be 1.3674 grams per 250 of anhydrous Na2CO3, because the whole point is to find the amount of water, and this is just the Na2CO3, not the water included. Alright, so question 5, there's two parts, don't miss out any parts. That's why we underline mass of water of crystallization, and hence, that means use the mass of water of crystallization to find the number of moles of water in 3.46 grams of the crystals. Alright, so we know the mass of anhydrous already, and the crystals is water included, so if I take away that, I'll get 2.0926 grams of H2O. And hence, using that old answer that I got, N equals mass divided by mR. I get that from this. I just have to move this now to moles, so I get mass divided by mR, and that would give me this answer, 0.116256 moles of H2O. Remember, I wrote out the mR, and that's equals 18, okay? Alright, so last question, finally, right? So the ratio of moles of water of crystallization to the ratio of Na2CO3, and hence find the value of x to the nearest whole number. So remember, ratio is the same as fraction, and a fraction is the same as division. For example, 1.2, or excuse me, 1:2 is the same as 1 divided by 2, or a half, a fraction. So what they're asking you is to divide the moles of water to the moles of Na2CO3. So I know the moles of water from above, that's that, and 0.0129 is the number of moles per 250. This entire question is per 250, so you don't have to worry about that. Now if I divide that, I'll get x, or the number of moles of water. And that will give me a lovely 9. Very nice and simple, and that's the nearest whole number. So in reality, this is Na2CO3, 9 H2O. Now that we have the question done, I have to tell you that there is an advanced version of this question. This question that I found this one is not as hard as the ones that I've seen. There is a particular one that I have in mind, but I'll probably do another video on that so that you can just give that full attention for the benefit of the doubt for you guys. Because nowadays the exam questions are getting more and more difficult and a bit more centered towards theory and understanding the concepts well rather than just studying off the techniques, right? But techniques are important, so I will do an advanced version video of this water of crystallization experiment. It's just the last part. Sometimes it's a percentage value, or they will ask you to find the percentage of water in that crystal, and then they will ask you to find X. So there is a small formula to do that, and I'll show you. I can't do this in this video because I'll have to do an entire thing all over again. I know I only have like 3 minutes left in this video, so I'll certainly do that very soon. If you found this video easy, or if you learned something new, please don't forget to like, subscribe, and share it, because you'll never know. There might be some other people who are in need, who really don't understand this. But remember, this is such an easy 50 marks. It's so easy if you know the technique, and it's always question 1. So God bless you. I know you really want to try and know your stuff well, or else you wouldn't be watching this video. So God bless you. All things are possible through Christ. The only way that I know of these things is, first of all, because of God, Jesus. Otherwise, I won't be able to do any of these things. So, best of luck for your exams, and you can do this. Goodbye.